Hello and welcome everyone to today's episode. Today we are going to be covering the following topics. All the timestamps are in the description below. And I hope you enjoy today's episode. So let's get started on these topics. Another import statement that is of interest. So if you look at this import statement over here, which is it's got from keyword, it's got SQL band, got linear model, and then import statement, and then the another module over here. But this isn't actually a module, because if you hover over here, you can see this is a class. So you've seen an import statement that if I scroll down here, you can see the import statement like this, where if I hover over here, you can see this is a module. And from this module, we are importing in the two functions and then aliasing them over here. Watch my previous explanation on this import statement. But notice here that we're able to import individual functions over here. So, but when you look at the statement over here, or actually, let me copy this, or I'll copy this and just stay at the top so you can see the differences. So you can see the ones in green over here, you can see they are modules over here. And you might be wondering, how come this is in green? So how come this, looks different to this import statement? So you can see they both start off with from. So notice here, these are modules. So when I hover over, you can see it says module. And if I hover over this one, you can see it's metric is a module, sklearn is a module. And within this module, you can see these two are functions. So you can see it's the function. But for this one, you can see that actually it's a class. So that's the difference. So you can't import a function from this linear regression. So if we look at where linear regression is used, you can see it's used here. And we are creating an instance of it. And when you create an instance of it, you can then see that we can use this function. But you can't use the fit function, for example, like this. You can't import it in. It says that this isn't valid syntax. This is because classes over here are complete objects that you need to import. So remember, this class is part of this module, and although these are modules, but they have functions directly inside them. So you don't need a class to use these functions, because you can imagine linear regression is a class because it needs to remember all the data that you supply to it, while mean absolute error and mean squared error actually are just functions that are able to work on a standalone basis. So they don't need to do or hold any data, while classes are able to hold data. But individual functions don't need to, because they just run and finish, and there's no need to do anything else. So I hope this explains the difference between why we have statements like this that is in green over here, but then there are situations where you can actually import standalone functions. But for classes, when you hover over, you can see it's a class, you cannot do that. So this has been a bit of a beginner's guide to machine learning, and I'm explaining different parts of Python as I go along. Check out my other explanations where I talk through this full example of machine learning in Python. Let's continue to look at the import statement and understand another variation that you will see as part of machine learning. So here you can see this is the math module. So you can see it's called a module here. And what we're doing is we are importing in a function over here. So notice when I hover over the name, it says it's a function. And then you can see this one is pi value, and notice it's a constant. So that means it's a variable within that function. So you can access variables if they are part of a module. So if we now try and do this, you can see if I do print of pi and run this, and you can see the value being printed here. Now if I take out this, so don't import this in, and now you can see Visual Studio Code is complaining to say that it cannot find pi, so it's undefined. And if I run the code over here, it would appear that it still works. So you can see it's worked. So you can see this has worked, but we haven't imported in. Why is that? And why is VS Code here is complaining that it's undefined, but yet it still continues to function. This is because the value of pi is in the cache, and it's just picking the value up from the cache of this program. So if I were to click on this restart button over here, and if I restart, and do you want to restart the kernel, all variables will be lost. So notice here, this is a big one. All variables will be lost. If we do this and restart it, and after the restart, now try and run this code, and what you'll see is you'll get an error. So do you see? Before, when we run this, we had it as part of the import statement, but then we removed the pi from the import statement, and now we get this error when we try and print it, because it's saying name error, and it's saying that the name error over here, pi, is not defined. So that's the error that we get. So although it appears that without the import statement, your code ought to work, right? And when you click the play button, it worked. But once you restart the kernel, or you can close the notebook and come back to it, it won't work, right? So we will just add that back in, and you can see we've just added the pi back in. And now when we run this, you can see that our code works and there is no issue with this. So just remember to always import in the functions, the variables for classes in your notebook. And once you remove the reference to them, although if I, for example, if I remove the reference then still click play on here, execute cell, it appears that it's working. So once you restart the kernel, it will stop working. So don't remove any references in your import statements if you are using them later in the code. Let's understand linear regression class over here. And let's understand the Python reason for why it is a class and not a module. So first of all, what is a class and what is a module? So as you can see here, there are some things like if you look at the metrics here, when we hover over the metrics, you will see it's module. But when we hover over the linear regression, you can see it's a class. And the reason it's a class is because it needs to hoard data. So unlike a module, which doesn't necessarily need to hoard data, a class can hoard data. So you could have two versions of this linear regression holding different data. For example, the data we have here, this is the size of the house and the price. So this is the data that we have. And what we do is we pass that data to our model. So here, what we're doing is we're creating an instance of that class. So what it basically means, if you think about it, like a module is like a recipe book, but a particular recipe for a cake, and that is a class. The reason a particular recipe is a class or considered as a class is because you can make several cakes out of that single recipe. So from the recipe book, which is a module, in there are several recipes, and of the one recipe you use, that is the class. Basically, it lets you create, if you follow that recipe, it lets you create cake, and that cake will have its own taste, it will have its own size, it will have its own name, it will look different to any other cake that you make of that same recipe. So that's why when you then make that cake, it's stored in this variable. So a particular version of that cake of that class is stored here, and then you can decorate that cake differently, you can change its taste and so on. So that's why the difference between a module and a class needs to be understood. So that's why, for example, here this is a module that you can import certain functions of and use them without it having storing the data. But with a class, you can actually store the data. So that's the difference between a class and a module. And that's why linear regression, because it needs to hold the full model. So it needs to predict the values based on the data over here. That's why it needs to store that data within the class. So that's one of the differences between a class and a module, is that a class needs to hold data and you can create multiple versions of it. So here we could have, for example, model 2, and that would have its own data. So you can then say, okay, model 2 will have its own data and it may have values of, P and Q, for example, whereas this one has the values for X and Y, which are these one X and Y, which come from over here. So that's why when you hovered over here, this is a class versus this is a module. So I hope this clarifies why linear regression is a class and not a module. So some of you may ask, what's the benefit of linear regression being a class? So you can see it's a class and it comes from this module, and then this is the main module. So sklearn is the main module, and then you have the sub module, and then within this module you have a class called linear regression. And when we import this class in over here, then what we can do is we can actually use that class, initiate that class. So here, for example, I'll delete this previous code over here. So you can see linear regression over here, and we're storing it in this variable. So by using this, what we're doing is we are initiating the class. So this is going to imagine you have a cake recipe. As soon as you start to put it together, you read the full recipe and try and understand it. This is what this is doing. This is initiating the class for it to be ready to accept data. So it's like having a cake mold, a cake template, which you're going to put the ingredients into. It's just getting that template ready for that cake before you put the ingredients in the pot or in the mold. So once you have that, you've initiated this over here. So you now have a copy of it. So you're not working with the original class here anymore. So that's the original, that's just a template. So once you have that template, you can think of it like an Excel template as well. So you could create an Excel workbook of a template, or a Word, you could set up a Word template, but then use it to create several documents. That's as soon as you start to use that template, go to File and click new from template. And then once you have a document in front of you, that's where we are. So a blank Excel workbook. And then you can use things like model.fit because model here is referring to that particular copy of this class. And here you're using the fit function and passing it to parameters. And then later on, when you then use model.predict, it's aware of its data that you've already passed it, because you had this data, size and the price. You converted it into X and Y. So size becomes X variable and price becomes the Y variable. And then you pass these over here, and it will go and create the model. And then you can use the predict function, because the predict function will have all the data it used for this fit function, and then it's able to predict the house price over here by supplying it a size. And then you can do other things, find out the coefficient and the intercept values as well, because these are the variables stored within that class, but they are aware of your data, so they know. So it's like the Excel template, it might be blank. Once you start filling in your data in Excel, then it will be your data that expects back. So for example, in cell B3, if you input your data, then B3 will say, that's your data in that cell. So it's no longer blank. It actually has the data that you input into that file, but the file that you created from the template. So I hope this explains why we have classes for linear regression and not a module. With Python, you see another type of import, which is importing functions, but also you can separate and import a different type of data. So here you can see we're importing a function over here. So this function square root is being imported, but you also can import pi. Now we all know pi value, which is 3.1459 and so on. So this constant is actually part of the math class. So when you import this, you are just importing a constant that will be available in your code. So if I were to run this, and you can see here the value of pi is printed and also the square root. Notice that the color, so yellows are functions and constant here are in this bluish color. And then you've got classes being imported in this green color. So this is the default color scheme in VS Code, and you'll see that across many other languages as well. So yellow usually means function, green means it's a class, and then you see this color, bluish turquoise color, as a constant. Now, if you take that pi out, do you think that variable actually will be available through our code? So if we take it out, and you can see here that it's the squiggly line to say it's not defined. But when I run this code, you can see that it still seems to work. It's a success. But the reason it's success is, remember that because you've already run this, these values are stored in memory. So pi has already been imported in once, and since it's been imported in once, it's still in memory. But if I were to restart the kernel like this, if I click on this restart button over here, and it says, do you want to restart? All variables will be lost. So this is important. All variables will be lost. And if I say yes and restart that, and now if I were to run this, then you can see we get an error to say pi is not defined. So it's not the case that do this statement, you can't use pi until you import it in. So you have to do pi like this and then run, and then you can see your code works and we get the output as we want it. And if you're thinking you can just simply import the full module in, so here we importing in the math module, but what you can see here is the function is not defined and pi is not defined. So if I were to run this, you can see that is saying square root is not defined. This is because by importing math in, you are not actually importing in any functions or variables stored within this module. So let's continue to discuss the import statement for machine learning. And you need to be aware that the import statement is really important. So here, what we're doing is when we say from math, import the square root and the pi. So square root is a function and pi is a constant value. So you can import variables stored within this module. So this is the module that's been pre-written, where you didn't have to write it. And we're just using the square root function. So we don't have to write it. And we're using this pi variable, which is a constant type. And we are just printing its value. So you may wonder, why do we have to do this? So here, if I comment this out, you can see that we get squiggly lines over here. This is because it's saying the square root function and pi cannot be found. Now you may wonder, well, we are importing in the math class, so why is it that these two don't work? So if I run the code, then you can see we get an error. We say square root is not defined. The reason this happens is here, when we had this import statement, you can see the squiggly line go away. The reason this happens is these square root and pi are literally, you might think a easy way to think is, are copied. So this function square root is copied from this module over to your code. So it's available to your code, and same with this variable. So they become part of your code. So just imagine you copy something from Wikipedia and paste it into your Word document, it becomes part of your Word document. But if you left it on the page and you just referred to it as a link, so here what we're doing is when we say import math, what we're saying is we just pasted a link to the square root and the pi variable, but we didn't actually make them available in our Word document. It's just a link, a hyperlink in your Word document that somebody has to click on. So that clicking part is what you need to think about. So when I comment this line out, you can see we get error. They're saying can't find that Wikipedia article, for example, in your Word document. This is because you have this poor hyperlink. The hyperlink doesn't actually give the details. So what you have to do is you have to use this method, which is you've called it math. So you use math.square root and math.pi, and that's what makes it work. So if I were to run this now, and you can see this code over here works. But remember, you can alias it as well. So you can MT, for example, for maths, and then if you alias that, you can see it gets the errors. So basically we're saying rather than calling it math, we want to call it MT. Just like imagine you have a friend and you want to give a nickname to your friend. That's what this is. This is known as alias. So what you can do is just type in MT and MT over here. And then you can see if I run the code again, this works. Now, another way you could do this is by using the asterisk over here and then take off this and take off this and then add the word from over here and add import over here. So it looks like this. So it becomes very similar to this one over here. And then you can see this works because the asterisk is saying is bring in everything. So don't leave anything out. So this also works without any issues and you don't see this squiggly line under here. So asterisk is a wildcard, basically mean bring everything from this module into my code and make it available. If you don't use the asterisk and you use the other statement like this, then this won't work because you're not bringing in everything into your code. Another thing as part of machine learning import statement is you need to be aware of this asterisk import method. So what this does is it brings over every single function, variable, property from this module over to your code and makes it available in your, what I would say is the namespace. So what we mean is it just makes it available in your code. So when you do this, you can, there are two ways to do it. One, which is using this method over here, and you can see we're bringing in the square root function and we bring in the pi value. So you know, when you look at this code, you know that from the math, we bring in square root and the pi. When you do it this way, the code is very readable. But when you do it this way, you don't know what you are bringing in and what you are overwriting. So here, for example, if you have pi over here, but we know pi also exists within this math module, what happens is we're overwriting its value. When we overwrite it and we print it, you get the output like this. It says, oops, because you have actually overwritten the previous value from math.pi. But if I comment this out and run this again, you can see we get the actual pi value over here. This is because we haven't overwritten it. Now, this method over here is very unclear, while this syntax is very clear. You know that you're bringing in pi from there. So I would avoid using this method and instead use this. So you know pi actually comes from there. So then even if you overwrite it, you go, ooh, actually I am overwriting pi over here. So it just makes it easier to find problem than bugs with your code. So this code will actually still work. You can see that it overwrites it, but when you comment it out, it does use the pi value from there. But by using asterisk, you're not really sure whether actually you're overwriting an existing function from this module. But if you use this syntax, even when you look at it, you go, ooh, I'm importing pi, but then I'm overwriting pi over here. So going back to, again, different styles of import statements, you can see you can import like this, the full library like that. And again, you can do that with this one. You can import to be very precise, you can import math, and to prevent accidental overrides of variables, you can import the math library like this and call it as MT. And then what you can do is you don't have to use the alias, so you can just leave it as math if you want. But if you do it as MT, then what you can do is you can refer to this as mt.pi. And notice this one is now different to that. So even though we are overwriting it, what will happen is when we run this, our value is coming from mt pi, versus if you were to just take that mt part out, and then you can see it's say overwritten and use this pi over here rather than that one. So you bring this variable in, it basically becomes part of your code, and then you can change that to anything you want. But using this method, you can just do that. But remember, you don't have to use the alias, so you can actually just, refer to it as math.pi, and that still works, and your code works like this, and we get the right output. So another important thing to be aware of using the import statement is when you use an asterisk like this and you import math class, which has a function called square root, and then you import complex math class, which also has a function called square root. And we know the complex numbers appear like this, while normal math class will actually give you a decimal place. So the reason this happens is we're importing in the math class, it will have a square root function. And when you run the second statement here, cmath, it also has square root. So what it does is it overwrites the math class over here and it replaces it with the square root function from cmath. So the output that you get over here, you can see is a complex number. But if I comment this line out and now try and run it, you can see we get 2.0 rather than we get a complex number representation. So the naming conflict is resolved like this. This one is the first statement. It will get overwritten by your second statement. And same, because you can actually declare a variable here over here and then make it another value. So for example, you can just make it and if we print that variable, because pi is available in the math class, so if we print that over here, and you can see if I run this, we get oops, but if I take the oops out, then what will happen is we get this one over here, the value of pi coming from there. And if I take that out, then we get it from the math class over there. So you can see that you may end up with naming conflicts and so on, where two modules could contain the same function. So in this case, square root was overwritten. And what you should really be doing instead of using these statements over here like this with an asterisk, don't use the asterisk. Instead, what you should do is use a statement like this, which is very clear, which says you're importing in the square root and the pi square root function and the pi variable, or you can do it in this fashion, which is if you comment that out as well, and if I comment this out and that, and you can do it like in this fashion as math, and then you know that can use math.square root, and you know that this is coming from over here. Now, if you don't do the import statement, you get error to say it doesn't know what math is. So you need to import math. You can also alias it as MT, and then you can use MT over here. So there are different ways of doing it. Just be aware of naming conflicts between modules, especially if they contain the same functions. They will get overwritten, and your own code could override certain things, such as the value of a pi, although it's coming from the math class, but you may end up overwriting it. So to be very precise, I would always recommend using this syntax over here for clarity, but you can also use this one because this one is a common syntax as well. I'm continuing on the import statement. So you can see some standard import statements that you can use within machine learning, but you may see another variation. So you saw this variation as well. You can use it like this and so on. So there are different ways of importing in modules. But one other final one that you may see I wanted to talk about was this one, where you specify the module name as a variable, and then using underscore function import, you use the variable name over here. So you want the math module. So this is similar to that syntax over here. And what you're trying to do is use this variable over here. This has the word math, and it will import the math variable, and it will store it over here in this variable. So this is just a variable that we have created called math. You can call it whatever you want. You can call it math2, math3, or whatever. That is not a problem. And then you can use this square root function. So this is similar to statements like this over here or like this. But the only difference is just storing that import statement like an alias. Think of it like an alias. So this is a bit like this. So you can alias that as MT. This is the same concept. And when you do that, you can then refer to it and use it like this. Another way it is possible is using the import lib. So here using the import lib, what you can do is you can use the import module function and give it the name of the module that you want. So in this case, math, and then you can access that over here. So for example, here you call it math, and again, this is just the alias or variable name, and you can then use the factorial function, for example, and then you can see if you were to run this, that's success, and we get the output. So by using these methods over here, what that allows you to do is maybe build some dynamic code that lets the user or some other logic, if conditions and so on, control what value this should have. For example, if the user says I want to access from the math class, you can actually make it dynamically access the math module and so on. So this is all to just make your code dynamic. The standard way is, of course, and the most preferred way is this one. I just wanted to touch on these methods because these do exist and you may see them, but I don't want you to be getting confused about them. But always try and stick to some standard method unless you're trying to do something very complex that requires this sort of these sort of statements. But as you can see, standards are just import like this, or you can use this flavor, which is you use the module name and import a particular section. So in this case, we're importing a class, but you can also import individual functions and so on. You can also import in variables that are declared within a module. So here, for example, this is a constant that we're accessing, like that's a variable in this math class, and you can also import just that one in. And of course, one other one that you see is like this one. You import it in with the alias, and then you can access, for example, so you can access it like this, mat.py, mt.py, and that comes through like this as well. So that's it. Catch you next time when I explain some more concepts on machine learning. But I just wanted you to be very familiar with the import statements and the different styles available.